almost real time right afterwards when the data was coming in, what was happening, and then using other NASA data sets and mapping the landslides that were occurring. Also, with SERVIR, we've teamed together with UN SPIDER, and the regional office in Central America and the one in Africa have become regional support offices in the context of UN SPIDER, and we hope to expand that now with ECMOD. This is just something that happened last week. We've got it's the hurricane season in Central America, and what we're doing is providing improved forecast information looking at that, and there was terrible flooding that we're now mapping similar to what ECMOD did in Pakistan together with other partners. Of course, in Central America you have harmful algal blooms or red tides. This is what it looks like from the air. Using satellites we can actually look at the chlorophyll concentration and map that on almost a daily level, and we're providing that information to the countries. We even got a response a few years ago from the government of El Salvador saying that that type of information saved their fishing industry $14 million that year because they were able to see where this algal bloom was, because it affects the shellfish and of course tourism, and be able to change where they were fishing and to keep their fishing industry going. So it's these types of products that Earth observations can provide, these applications that can provide direct societal benefit. This is another example. In Guatemala, where I used to live, there's a lake called Lake Atitlan. It was just named one of the 10 most beautiful lakes in the world. It's surrounded by volcanoes. Of course, the fact that it's surrounded by volcanoes and is beautiful, you also have a watershed that is completely enclosed. And due to population increases and contamination, just last year they had a horrific cyanobacteria bloom, as you can see in green, in almost the entire lake. And that image made the front page of Guatemala's largest newspaper and created a massive response to actually clean up the lake and the surrounding watershed. So again, another example of the benefits of Earth observations. In Africa, there are two main problems or issues in Africa related to weather and water. One of those is too much water, and the other one is too little water. So you have floods and droughts. And what we're working on right now is improved flood potential, and using the NASA TRIM satellite and looking at flood forecasting and flood potential across the continent, and then taking it down to the basin scale and using a model called the CREST model that we've now implemented, and it's functioning in the SERVIR Africa node at RCMRD. And we hope to expand that in other basins. And of course, they also have issues related to disease and Rift Valley fever and climate change. You're seeing changes in temperature, you're seeing changes in humidity across the continent of Africa, and that's affecting the outbreak of Rift Valley fever, which is affecting and killing the livestock. And it's a major problem in the region. So we've teamed with other NASA centers and have created a forecast model that looks at the conditions that enable this Rift Valley fever. And of course, the absolutely horrific floods in Pakistan recently, and even though we had not dedicated the SERVIR node officially, I want to thank the team at ECMOD who spent, and other partners who spent many, many hours, and I'm sure countless nights without sleep to help develop some of these mapping products for the flooding that was going on, using NASA and other data from the International Charter for Space and Major Disasters. Other issues, of course, related to climate change adaptation is what we're addressing in SERVIR. We've created a product. So many people talk about climate change, and they talk about a forecast that it's going to be warmer here or drier here. But we've created a tool called the Climate Mapper that actually enables people to almost in like a Google Earth context to actually then look at that data. So they can pull open climate models and they can put them on the globe and spin them around and play with these climate models and see what they are projecting. These are helping climate adaptation managers really see and understand what's going on. Because it's one thing to hear about these models, it's another one to be able to use and to interact with these models. So I encourage again the youth ambassadors, please feel free to use this tool and to share that with others to look at some of these climate models. And of course, it's one thing to say that the temperature is going to be warmer or it's going to be drier in one location, but it's so important to then tie that to relevant indicators, such as how climate change is affecting biodiversity. And we've done that in Central America. We're working on that in Africa, and I know that there's similar efforts that are going on in the Himalaya region. So it's very exciting to be able to tie that and look at how climate change will affect biodiversity over the next several decades. And of course, land management and RED. We live in a world, again, with increasing population. I think the statistic this morning, we're looking at a population of 9 billion people on the planet. And this is an area that, again, where I used to live in the early 90s in Guatemala. What you're looking at is a false color image where red is forest and blue is deforestation. And right here you're looking at an image from 1986. And this was an area that I used to go hiking in, and it was beautiful forest with jaguars and parrots and toucans. It was remarkable. And they put a road in, and you can see the road that was put in 1985, 1986. And then in this image, 1995, less than a decade later. And the scale of this image is about 100 kilometers across. So you can see just from one road that was put in, the massive deforestation that occurred in less than a decade. And that's in one location. And of course, I'm sure many of you have seen this image, what the world looks like at night using satellite data. So where I showed you was just one small location in Guatemala, and we're seeing this massive urbanization that's occurring across our planet. But it's Earth observations that are helping us to really see that and appreciate what's going on to our planet. And then to bring that back down to this national scale and tying it to RED Plus and carbon stocks and doing national types of analyses like we recently did in the country of Belize and hope to expand this methodology, looking at the forest and the deforestation at the national level. In the future, many countries, I'm very excited again about the context of GEO and GEOS, and the countries are working together and data sets are becoming interoperable. And NASA, again, together with its international partners, are creating an entire new generation of satellites to understand and protect our home planet. Satellites that are looking at things like soil moisture, or looking at small changes in gravity, so you can actually look at groundwater and look at these aquifers and the changes in these aquifers from space. So there's a remarkable generation of new satellites that are coming on board, and we hope as NASA, teaming together with so many great partners, and many of them in this region that are producing very important Earth observation satellites, we can work together in the context of GEO and GEOS and SERVIR at the regional level and use this information for improved knowledge and improved decision making. Also taking advantage, hopefully, of the International Space Station. Of course, the International Space Station is occupied all the time by astronauts from around the globe, and we're now looking at using the space station and putting, hopefully, a camera or a series of cameras on the space station to look at the planet Earth, to provide an additional tool in the arsenal for Earth observation, because the space station passes over 95% of the world's populated area every 24 hours. So I have this dream, this vision, that we could have a camera up there to, again, provide another tool, and that different people in the different SERVIR nodes can actually task the International Space Station when there's a disaster and when there's an extreme event to provide new and different types of data sets. Now, that's now. Let me go back in time. What you're looking at is about 2,000 years ago, and you're looking at the Maya city of Mirador. Of course, the Maya civilization, one of the greatest civilizations ever in the history of the earth. Phenomenal mathematicians, phenomenal astronomers. They were really the first ones that were looking at the movements of the planets, understanding them with incredible accuracy. But the Maya, as you can see, they cut down all of their forests. They were brilliant, but in developing their architecture, they cut down all of their forests. And you can see that they were starting to burn in the back here. You can see the smoke coming off, because to create the lime plaster for their pyramids, they had to burn trees. And you had to burn 20 trees for every cubic meter of lime plaster. That was, for this one city, it was several feet thick on each of these pyramids. Now, that was a couple thousand years ago. Around 800 AD, the Maya civilization collapsed. It's believed that over 10 million people perished. They didn't leave, looking at all of the records, and it was one of the most densely populated places on planet Earth at the time. And it's now believed through most archaeologists and researchers that the reason that the Maya civilization, again one of the greatest civilizations, collapsed was because they had cut down all of their forests, and they started seeing that with cutting down their forests, it was creating a more desert-like environment. The clouds formed higher in the sky and later in the day, resulting in less rainfall. And in fact, they were changing their own climate. And it was this local climate change together with regional factors that caused the demise of one of the world's greatest civilizations. Now, the Maya, brilliant people, but they were not able to adapt to their changing climate. And today, we have new tools. We have Earth observations, we have communication technologies, we have youth ambassadors that are communicating this information to the young people who are our next generation of leaders. They can take this information and help us